So for electron configuration, you just have to remember two things. One is period number, and period just means row, so this is period 1, period 2, and then which block is it in. So you have the S block, all of this, D block, all of this, P block, all of this. Remember that the S helium is still in the S block. You can kind of see that because if you push it over, it'll fit. And then finally, the F block right here. So each one of these elements counts as an electron. So you can think about it as each one of them counts as one, and that'll be important when we start. So let's start. So electron configuration for hydrogen, right? For hydrogen. So let's see. What period is it in? Well, it's in period 1, right? And then what block is it in? It's in the S block. And like I said, it counts as 1. So since there's 1, it'll be 1s1. So that's pretty easy, right? So let's continue on. So for helium, right? So what do? I look. So helium is in what period? In period 1. What block is helium in? It's in the S block. Finally, since like I said, each one of these counts as 1, so all I'm going to do is add it up. So 1 plus 1 will be 2. And since they're in the same period and the same block, I'll add them together. So it will become 1s2. So just to go back, helium, all I did was I'm in the same period, right? Same block. And since each of these count as 1, I'm just going to add them and it'll be 1s2. That's it. So moving on to lithium. Lithium is I wrote it down, so 1s1, right? Because that we start from the top and then just work our way down till we get to whatever we need. And right now we need lithium. So we work our way from the top. So we have 1s1, same as the original, right? Hydrogen. 1s2, because each of these count as 1. Finally, lithium. So period 2 and then 2s1. Because this is still in the S block. So it'll be just 1s2, 2s1, right? So pretty simple. So next, beryllium. So we have beryllium right here. Like I said, each element counts as 1, and if they're in the same block, you just add them. So we work our way from the top, 1s2, right? 1s2, and then 2s2. Because since these are in the same period and same block, we just add them. So 1s2, 2s2, is they're both in the same block. So 2s2. Moving on, we have boron, right? So boron, we add another block because suddenly we were only doing the S block now, but now we're in the P block. That's not a problem. So we start from the top once again, 1s2, 2s2, and then what period are we on? Right? So that'll be period 2. And then now what do? Well, we look what block are we in? Well, we're in the P block, right? So all we have to do is say that. We're in the P block. 1s2, 2s2, because this is the S block. And finally, what period is this in? It's 2, right? For boron, it's 2. What block are we in? We're in the P block, 2p. And then since each element, it just counts as 1, so we just have 1. So how many elements are in the P block? Just 1. Continuing, neon is right here. So work our way down. So we have 1s2, 2s2. So neon, right, is in the P block. This is the P block. So that's why I have 1s2, 2s2, and then so the P block, right? So we're still in the second period, P block, and we just count because each one of these elements counts as 1. So 1, 2, 3, 4, 5, 6, right? So it'll just be 2p6 because we're in the second period. There's 6 elements, so each one of them counts as 1. Since they're all in the P block, we count it as 2p6. It's not bad. So we keep going. So now, as you can see, this could get really long because if we did an element right here or here, right, we would have to because we're always starting from the top and work our way all the way down to get to whatever element we need. So now I'm going to introduce a shorthand, right? A shortcut. And then shortcuts are always good, right? So the shortcut, what you do is you can only use the shortcut with this group, right? Meaning, so I'll just explain it through examples. So for example, Na, right? We have Na right here. So let's do the long version. Na is what? So we work our way from the top to Na. 1s2, right? Is this S block? 2s2, 2p6, because this entire thing is the p block. This is the second period, so it's 2p6. And then we come to Na, and this is the third period. And Na just counts as 1, so it'll be 3s1. So we had 1s2, 2s2, 2p6, and 3s1. Now, if you notice, there's actually a pattern, because Ne actually has all the same electron configuration as Na. So what you can do is actually replace that with Ne. So the shortcut, if you haven't figured it out, is whenever you're in a period, right? Whenever you're in one of these periods. So for example, aluminum, right? If you're in this period, you take the noble gas. So these are called the noble gases, or the very last group. So whenever you're in I had aluminum as the example. So aluminum is in the third period, right? So you take the second period's noble gas and you write that in parentheses, or I'm sorry, brackets. So if I have aluminum, I would write, so aluminum's in the third period, I would write the second period's noble gas in brackets and then just start doing my electron configuration from that period. So my example was Na, right? So since Ne has all of this, I can replace all of that with Ne. And that makes sense, right? Because Na's in the third period. So all I would do is go up and then go to the last group, and that would be Ne. So I would just have Ne and then just start my electron configuration. So I would start with Ne, work my way down. So I would start with Na. Na is in the third period, and then it counts as 1, so it'd just be 3s1. So more practice, argon, right? So argon's right here. So what I do, well, I'm in the third period, I would go up, go to the last group, that would be Ne, so I have Ne, and then I would work my way down to argon. So it's always left to right. Okay, so it's Ne, so I'll work my way left to right. So 3s2, right? 3s2, and then going over, this is the p block, the entire thing. This is the p block, and I'm still in the third period. So it would be 3p6. Why? Because each one of these elements counts as 1. So 1, 2, 3, 4, 5, 6. 6 in the third period, so it's 3p6. Now, let's make it a little more interesting. So for the D block, right? So far we've done the S block, the P block, but we haven't done the D block. So the D block's a little bit different. You'd assume that you just have to do 4s2, right? That's what the pattern so far. We just do 4s2, 4d, whatever, and then 4p. But actually it changes. For the D block, you always have to subtract the row number, aka the period number, by 1. So what does that mean? Well, let's do Fe as an example, right? So like I said, Fe, so we're in the fourth period, right? So we just go up, see which element is last, that's argon, and then we start our way down, left to right. So 4s2, work our way to Fe, and then just count, right? So 1, 2, 3, 4, 5, 6. So that'd be 6 in the D block. But we have to actually subtract the period number by 1. So I know that's a little weird, but you can just remember that if you're in the D block, you just subtract by 1. So you start from argon, right? Argon, work our way left to right, 4s2. As soon as you hit the D block, you remind yourself that you have to subtract by 1, the period number. So it'll be 4 minus 1, 3, and then just count to your element. So 1, 2, 3, 4, 5, 6, and that's where I get 3d6. So more practice for Zn, right? So since it's in the 4th period, we start with the 3rd period's noble gas, and then we just work left to right. So 4s2, and then just count all the way to your element. And remember, as soon as you hit that D block, you subtract by 1. So it's going to be 4s2, 4s2, and then subtract by 1, which will be 3, right? And then D10. Why is it 10? Because each element counts as 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3d10. Now, ZR, right? More practice. This practice is the best way to understand. So ZR, right? So once again, ZR, we're in the 5th period. We look at the 4th period's noble gas. So we start with krypton, and we work our way left to right down. So we have 5s2, and then as soon as you hit that D block, you subtract by 1, so it's going to be 4, and then you just count until you hit your element. So we have ZR, so it's going to be 1, 2. So it'll just be 5s2, 5s2, and 42. Now SB, right? SB is right here. Once again, SB is in the 5th period, so we go up. We have krypton, and then work our way down from krypton, left to right. So 5s2, right? 5s2. As soon as you hit that D block, you subtract 1 from the period, so it'll be 4. In an entire D block, it'll be 4010, right? And then we count to in the P block. Remember, the P block's not changed, as we've seen from here. The P block doesn't change number. It's only the D block. So it's 1, 2, 3, right? So it's still 5, and then 5p3. So I want to go over SB one more time just to make it clear. SB, start from SB. We see that's period 5. Okay, so start from krypton, and then work our way down from krypton, left to right. So 5s2, right? 5s2. As soon as you hit the D block, you subtract 1 from the period number. 5 minus 1 is 4. Count all the way to your element. So we count all the way. That'll be 4010. Now we hit the P block, and P block's normal. So once again, we're in the 5th, right? 5. And then count to your element. 1, 2, 3, 5p3. Now, for the final block, F block, right? F block's this one. Now, we do the same similar thing that we did for the D block, except now we subtract by 2. Now, this is just something you memorize again. Subtract by 2. So let's try it. So we have PR, right? We have PR as our element. So what do? Well, these two, right, fit where the stars are. As you can see, the 1 star is here, 2 stars are here. So this star fits right here. These 2 stars fit right here. So this fits right here. So what does that mean? Well, it'll be in the 6th period. So PR, right? So PR is right here. So what do? Well, PR is in the 6th period so far. And then we go up, so it'll be xenon, and then we go down from xenon, left to right. So we have 6s2, right? 6s2. And like the rule says, subtract by 2 the row number, period number actually. So 6s2. And remember that this is still 6. But since this is the F block, right? I'll just show you that. This is the F block, right? So we have to subtract by 2. So that's what we do. So like I said, since this is in the 6th period, we do 6 minus 2 is 4, right? 4F, because that's the block we're in. 4F, and just count left to right. 1, 2, 3 until you hit your element. So it'll be 6s2, 4f3. That's just something, once again, you memorize. And I want to review that again just to make sure that's clear. So the lanthanide and actinide series fit in these two blocks. So this would be period 6, this would be period 7. But when you do your electron configuration, it would look like this. So we're doing PR. So PR is right here. So PR, since I said this is 6 and this is period 7, this is period 6. So I would go up, right, xenon, and work my down way from down from xenon, right? So it'd be 6s2, 6s2, and then 6s2, and then from here, right, we go to the F block. So in the F block, you subtract by 2. So it's going to be the period number 6 minus 2 will be 4 for F. This is the block F, and then you count to your element 1, 2, 3. So 4F3. So more practice with that, and this is combining everything we know so far. Just so it'll be like the hardest case you'll see with electron configuration. So let's do Rn, right? Rn's right here. This will combine all of our knowledge. So Rn is in the 6th period, right? So we go up, we see that we have xenon, we're working from xenon, and we work our way down. So it will be 6s2, okay, 6s2, and then we move into the F block, is suddenly there's the gap, right? So we move into the F block. We realize that we have to subtract by 2 from the period number, so it'll be 6 minus 2 is 4. And since we're in the F block, F, and so all of this is 14. If you count all of this, it's 14. Now we move into the D block. We remember that it's since we're in the 6th period, right? It's going to be 1 minus the period number. So it's 6 minus 1 is 5. You count all the way across from left to right, and that's 10. All of this is 10. And then you count to your target element, so it's right here, and we hit the P block. Remember, the P block's completely normal, so we leave it as 6, and then we count 6p6. And that's combining every single block, S, P, D, and F. So to review that one, Rn. So we have Rn. We're in the 6th period. We go up to the 5th period. Look at our noble gas, which is xenon, right? So going down, it's the 6th period. So 6s2. And then we hit the F block. We remember that we have to subtract the row number by 2. So it'll be 4f14 because we're going from left to right. Because we need to get all the way to Rn, so we're counting left to right, right? So this will all be 4f14. And then we go into this row, right? And this is once again 6. So since this is the D block, you subtract it by 1, as I wrote right here. If you're in the D block, you subtract the period number by 1. So since this is period 6, this will be 5 D10. And then finally, you left to right for the P block, which is completely normal. So it'll stay as 6, so 6p6. So now you can do nearly every single electron configuration. The only thing is that there actually are some exceptions to the rule, meaning everything that I've taught you so far will always be the same. That's how it works. There's no changes. Now there are exceptions to this rule, because if you follow the rules I taught you, they won't work for these exceptions. Now I'm going to go over the 5 exceptions that were tested for me in my college, but just ask your professor or teacher what exceptions will be tested, just to make sure. But I think that these 5 will be the ones that they'll test you on. But there are more, so if your teacher or professor wants you to learn those, then you can ask them and then learn that. Because there's a large list. But I'll go over the 5 common exceptions. So the exception I'll show is chromium, right? So chromium starts right here. So let me do the standard procedure and see what happens, right? So I go to chromium, I see that's the fourth period, I go up, I see that the argon is the noble gas I will use. So you see argon right here. And then I work my way down left to right. So it'll be 4s2, and then I count. And as soon as I hit the D block, I remember that I have to subtract by 1. So it'll be 3, and then I count 1, 2, 3, 4, right? But that's actually completely wrong. So for the exceptions, what usually happens is that they donate from the S block and give it to the D block. See how the right electron configuration donates from the S block and gives it to the D block. And this is because it's more stable in this electron configuration, and that's why. So for these, you just have to also memorize these, but they're not too bad because they have a little pattern. So Cr and Mo are on the same group, and then the other three you need to know form I guess backwards L, right? So Cu, Ag, and Pd. So let me go over Cu. So Cu's over here. So let's do the old method. So Cu is 4, period 4, I go up. So period 3 is argon. And then argon, right? So that's our noble gas, right here, argon. And then I do 4s2, and then I would count, right? I would count all the way here, and then I would get, and then realize that I'm in the D block, so I'd get 3d9. However, that's wrong, because it's not stable in this electron configuration. So what it does is it donates one electron, and so it'll become 4s1, 3d10, because it's more stable in this configuration. And once again, you just have to memorize these, but yeah, so it's just these two and like a backwards L. So more practice, MO, right? So MO is right here, MO. So once again, I'll do the old method. So 5, right? So I'm period 5, krypton, and then I would do 5s2, and then once I hit the D block, it'd be 4, right? 4, and then 1, 2, 3, 4, 44. But once again, that's wrong. What it does is it donates one electron from the S block to the D block. So, but you see the pattern, right? So if it's in the fourth column on the D block or the ninth column, you should be on alert and remember that it could be an exception. And then what it'll do is if it's 4, it'll become 5. If it's 9, it'll become 10. And just remember to subtract 1 from the S block. Now palladium, it's a little different. Even in the exceptions, it's a little different because it's right here, right? So we would have krypton, 5s2, and then we would have a 4, right? Because 5 minus 1 is 4, 48. But the thing is, this one actually jumps 2. It actually takes away 2 of the electrons and becomes 4010. So that's a little different. So just remember, palladium is a little different because Cr and Mo are the same. Cu and Ag are, since these two are in both the same groups, they act the same. But since Pd is all by itself, it acts differently. So that'll remind you that it jumps 2 electrons, so it'll be 4010. The final one is just Ag, and Ag is, like I said, krypton, and then it'll be 5s2, and then as soon as you hit the D block, it'll be minus 1, so it'll be 4, and then you count, it'll be 49. However, it's more stable when it's 10 electrons. So it'll donate 1, let me zoom in a little bit. It'll donate 1 from the S block to the D block, and it'll become 5s1, 4010. So there it is. You should be able to do any electron configuration now with all of these rules, even the exceptions. So with a little practice, this will become second nature, and I hope that helped. And thanks for watching.